Hi, I'm Old Sneelock. Welcome to another episode of Old Sneelock's Workshop. Why am I washing this down rather than using the wire brush and just taking the paint off? Well, when these things were being cast, there are imperfections in the casting. And they were filled with putty, like this right here. If I take that out, I've just got to put it back because there's a hole in the casting. So I'm just cleaning off the surface, washing it down with odorless mineral spirits, and that will make it so that when I paint it, the paint will stick. And it won't remove the putty that is used to fill the voids in the casting. Call that porosity. Can come from a variety of things. You know, you can have sand inclusions where a bit of the sand mold breaks away and falls inside the mold and takes the place that normally the iron would fill and stops the iron from filling it. The other thing I'm doing is looking for cracks or damage. Anything used like this is, although this one, to all intents and purposes at this point, I can pretty much say was not terribly abused, because there's very little damage to the dies. Doesn't mean it wasn't dropped at one point or another, but the only die that shows any real wear on it is this one right here, and that's not of any consequence. That will still shear very nicely. And that's also why I'm not using a steel wire brush. I'm using a brass wire brush. This doesn't cut the paint as easily. It will, if you keep working at it, it'll cut through the paint. But usually by hand, and the amount of effort I'm putting into it, I'm not going to damage the substrate to the point where I have to do major repairs to it. Big thing right now is get the dirt and grease off so the paint will stick. And I'm going to paint it when it's disassembled. As you can see, these areas here that don't have any paint on them, not important. I mean, obviously it's lasted at least 50 years. They stopped making them in 1970. No, take that back. Paint's lasted a long time. I don't know exactly how long. There's no serial number on this that I can determine. So trying to say how old it is going to be tough. Doing maintenance work is mostly what I'm doing here. You clean, because dirt causes problems. Biggest enemy that a maintenance person fights day in and day out is just dirt. Sand is abrasive, sand is everywhere. And it causes everything to wear out. So you want to clean the grease out of something which holds sand and grit and get it down to a clean surface so you can put in fresh grease. And paint, even though it has an aesthetic purpose, is mostly to keep oxygen away from the surface of the material. Because oxygen corrodes nearly everything it touches. The reason aluminum is considered to be corrosion proof is because it immediately develops a thin coating of aluminum oxide on the surface. Yeah, it corrodes. It corrodes so fast and seals up such a tight surface that oxygen can't get to any of the material underneath it. Aluminum is voracious in combining with oxygen. And that's why when you're running an aluminum melting furnace, you don't want to put anything wet in the furnace. When I worked for United Technologies, we had a direct chill casting pit and recycled all the scrap coming off the processing. Chips, butts, cutoffs, everything. Because you can put the aluminum back in the furnace and melt it again. There was a standing joke that the first pound of aluminum ever cast in that shop is still in there somewhere, recycling around. But the reason you don't want to put water in an aluminum melting furnace is molten aluminum is even more voracious because the surface is constantly cleaned of the iron oxide. There isn't any iron oxide on the surface to prevent oxygen from binding to the aluminum. Well, water has got 2 parts oxygen to 1 part hydrogen. And the aluminum has got a strong enough attraction that it'll pull one of the oxygen atoms out of the water molecule. that forms hydrogen peroxide, which is rocket fuel. And when you have hydrogen peroxide in a heated environment, especially one where there's open flame like there is in an aluminum remelt furnace, because they use reverb furnaces, which plays an open flame over the surface of the aluminum to be melted. When you have that kind of a situation and introduce hydrogen peroxide, it immediately burns. It turns into water again at a high rate of speed with an accompanying amount of energy released. So it generates a huge boom. When you have a huge boom in the presence of molten aluminum, you get aluminum splashing. Yeah, think of 1,000-degree aluminum, 1,050, 1,100 degrees, 1,200 if you run it hot. And localized heating can bring it higher than that. But anyways, you take molten aluminum, put it in the presence of rapidly expanding gases, and it splashes. And when it splashes, if it gets on you, aluminum is hot, but it's not hot enough to immediately turn your surface humidity, surface water on your skin, sweat, into steam. So the aluminum chills and it forms around your skin like aluminum foil. It's still very hot. Think of wrapping aluminum foil right out of the oven around your arm or your face or any part of your body. That's not a pleasant thought, is it? Now, I have some friends that discovered that when you play silly games, you win silly prizes. And they thought it was fun to take a pop can full of water and throw it in the furnace. Because one of the things that you had to do in aluminum melting furnaces was to clean the dross off the walls, because the aluminum oxide would build up and interfere with everything. So they had to take a long-handled tool, kind of like a giant spoon, and clean the dross off the walls around the doors so that the doors would seal. And when they tossed the pop can full of water in there, it went boom and knocked all the dross off. Of course, it also sometimes knocked the brick out of the roof or out of the wall, and that would be an obvious tell that somebody had been screwing around. And it could cause the furnace to leak. The reverb furnaces at UTC, one of them held 150,000 pounds. That was the main melting furnace. And the other one held 100,000 pounds. That was the holding furnace. And they would pour molten aluminum out of the holding furnace into the direct chill casting pit. And I won't go into a long explanation of what direct chill casting is, unless somebody expresses an interest. If you pop the hole in the side of one of those, you're either going to have 100,000 pounds of aluminum out on the floor, or you're going to have 150,000 pounds of molten aluminum out on the floor, which will spread to cover a huge area before it chills off. The only saving grace to aluminum is it cools quickly. And contrary to prudent thought, one of the remedies for a leaking furnace was to spray water on it. Yeah, water, the enemy of aluminum melting. Spray water on it, chill off the outside, trying not to get water underneath the end of it, where it would get trapped and cause it to explode. Spraying a fine mist of water on the outside would chill off the aluminum, and the aluminum would form a plug and stop the leak as soon as the temperature got below melting point. So, how'd we get here? These parts are ready for masking and then paint. I want to mask off this surface. This one doesn't need it, but these two die pieces need to fit closely together. So even if I put paint on them, it's going to shear off, so it's better to not paint them. And the other rags go in the steel garbage can with a lid so that they don't spontaneously combust. And this stuff will go out and get painted in the garage. Actually, it's supposed to be nice out today, so it'll probably get painted in the backyard. Standard old Sneelock gray. My favorite colors. First coat, Rust-Oleum Universal Bonding Primer. Bonds to any surface. Works well. A couple of thin coats of primer, and then we'll put the top coat on. It'll save a lot of flipping around. Make it so I'll miss fewer spots. I like that primer. It says wait half an hour to touch it, an hour to handle it, but you can put a top coat on it at any time. The only problem with spray painting outside is bugs. They do like to land on things. And there's a whole breed of bug that just loves to land on paint. Okay, primer's done, top coat's on. I think it looks pretty good. Gonna let it sit for a couple of hours, no rush. Then I'll be able to reassemble it. In the meantime, I got some other work to do on some of the fittings and pieces. If you have any suggestions for a new video, questions about today's video, or any of the other videos on the channel, just drop a note in the comments. You know I read them all. Thanks for watching. This video is not to be viewed by anyone under the age of 13 in the U.S. or 16 in the European Union, without the express written permission of the parents or legal guardians of the underage person. Such written permission must be on file at the local government entity in charge of enforcing the rules and regulations established by the FTC. Anyone violating these terms is admitting by default that they hold harmless the owners and operators of this channel. Any and all questions should be addressed to your local branch of the FTC.